initial intention with the UAV program was to investigate crash scenes primarily on the interstate. So whenever you have interstate crash occur, it causes a closure. That closure, every 4 minutes you get a mile backlog of traffic.
When we have queued traffic on the interstate, we increase the rate of crashes by approximately a factor of 24. So we're using drones or UASs to reduce the time spent documenting a crash scene. So with a drone, we can quickly fly a crash scene, typically in the order of 3 to 5 minutes.
The decrease in the exposure of emergency responders at the crash scene and on the roadway makes it much safer for our officers, the fire department, and EMS to be out there on these scenes because we can quickly capture and clear those scenes and get the road back to normal conditions.
As you are flying, you collect images every 2 seconds. You put it in a software, and then within a couple of hours you have a digital 3D model of the scene you have. You can use it for visualization, you can use it to print a 3D model similar like that for evidence, or you can do your own measurements and analysis. So the sheriff's office, they take this model and then they do the measurements from this one, and then based on the analysis they can recreate the dynamics of the cars during the accident.
It's been a collaborative partnership between Purdue University and the Sheriff's Department, and so we've both been able to grow and do research and shorten that learning curve that both of us would have experienced had we been doing it individually.
The next step on this is scaling this. We need to now move beyond 2 to 3 agencies in the area using this routinely to a more scalable statewide deployment that's used by all first responders and the state police.